Hello everyone, welcome back. Let's now look at section 1.1, sampling. Data can be collected in a variety of ways. One most common method is through the use of surveys. Recall the example. We want to know the average height of all SHSU students. We cannot get the exact number for that average because census is almost impossible. So we have to collect a sample and then use the sample average height to represent the true population height of all SHSU students. So researchers use samples to collect data and information about a particular variable from a large population. So here the large population is all SHSU students. And then the variable is height. And one student can also collect data from a men's basketball team. So this is a possible sample. But it is not a good sample because it will cause overestimate problem. Because men's basketball team members, they're usually very tall, so the average height gonna be higher than the true population height. So it's an overestimate problem. Then we have an issue. So to obtain sample that are unbiased, so which is very important, unbiased. What is unbiased? Give each subject in the population an equally likely chance of being selected. So to get unbiased samples, statisticians use 4 basic methods of sampling: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Let's first look at simple random sampling. A simple random sample of size n is a sample chosen by a method in which each collection of n population atoms is equally likely to make up the sample, just as in a lottery. We can look at the exercise. Random select 5 numbers between 1 and 100 inclusive. So if we want to get a simple random sample, we have to make sure all the numbers between 1 and 100 got equally likely chance to be selected. So we can do that using technology. The first method we have here is a online random number generator. So we can just Google random number generator, and then there will be a lot of options. And this link just provide us one web random number generator. It's just one of those many options. We can click the link and it'll direct us to this random number generator. So 1 to 100, right? So we can click generate, then we'll get a number between 1 and 100 inclusive. That means it's possible that we got 1 or 100 from the result area. So we can keep clicking generate, and then we can generate numbers. If we want to do 5, right? The exercise, we want to select 5 numbers, then we can just click that generate for 5 times. Or we can use this below comprehensive version. So lower limit, start from 1, upper limit 100. And we want to generate 5 numbers. Allow duplication in results, yes. Because when we click this generate for 5 times, it's possible that we got same result. So that means we allow duplication in result, or we call it sample with replacement. And then the result, we can put that in all the numbers in order. We can do ascend or descend we don't have to. So the option here, I select no. And type of result to generate, we want integers, right? Between 1 to 100. So we select that option and then we click generate. And the 5 numbers are 84, 98, 7, 56, and 35. Okay, that's just method 1. And method 2, the calculator, right? So our calculator is a software that we can install on our computer. After we got that software installed, we can use it as a regular scientific calculator. For example, let's open R. And if we calculate 20 squared, we just need to type 20 squared, and then we can get a result 400. And then if we want to look at the random sample, so we have the way to get it here, right? So we just need to type in sample and open parentheses from 1 to 100, comma, how many numbers we want? 5. Replace equals true, right? That means we allow sample with replacement. And then we got these 5 numbers, 82, 3, 83, 81, and 15. And if we repeat that process, we got another set of 5 numbers. They're randomly sampled from 1 to 100. We can keep doing that. That's how we use this R to get random samples. Okay, so for this class activity, we can try that ourselves. Random sample 2 students to receive 1 extra point for test 1 using method 1. And then we random sample 1 student to receive 1 extra point for test 1 using method 2. So method 1 is here, and then method 2, we're going to use R. Okay, that's simple random sampling. And let's look at systematic sampling. A systematic sample is a sample obtained by selecting every case member of the population, where K is a counting number representing the sampling frequency. So imagine waiting alongside a line of people and choosing every third person. That's a systematic sampling. To begin the sampling, we want to choose a starting place at random. So we call it random start point. And that's our first sample actually. So select the atom in the starting place. And then we're gonna go every case item after that. So if we look at this example, the random starting point is here, number 3. And then we let K equals 3, right? So every third number after that. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So then we select the bottle number 3, 6, 9, 12, and 15. So in order to do that, we actually have the population ordered, right? So systematic sampling is sometimes used to sample products as they come off an assembly line in order to check that they meet quality standards. For example, a bottle of milk, right? So we can use systematic sampling to get a random starting point and then just sample every 10th bottle from the assembly line. Okay, next one, we're going to talk about stratified sampling. A stratified sample is a sample obtained by dividing the population into subgroups or strata according to some characteristics relevant to the study. Then subjects are selected at random from each subgroup or stratum. Note that there can be several subgroups. The members of each stratum are similar in some way. So for example, we have all 379 students as the population. And then we want to collect a sample from all 379 students from this population. So what we can do is we separate this whole population into subgroups or strata based on some similar characteristic. So for this group, we can say male students. And for this group, female students. So that's called the subgroup or strata. And then we're gonna do simple random sampling from those subgroups. So we can do for example we simple random sample 4 students from the male group, and then again 4 from the female group, and then this 8 students gonna be our sample. And again, stratified sampling, we first separate the population into subgroups, and then we do simple random sampling from each stratum or each subgroup. And then all the simple random samples forms the strata sample. Then we can also look at cluster sampling. It is similar but not the same. A cluster sample is obtained by dividing the population into sections or clusters, and then selecting one or more clusters at random and using all members in the clusters as the members of the sample. So the difference is for stratified sampling, we do simple random sample from each stratum, each subgroup. And for cluster sampling, after we got all the subgroups, we select the subgroups, not members from the subgroup. So after we simple random some subgroups, then all the members in that subgroup are considered as the cluster. For example, again, all 379 students. So that's a big group, big population. And then we separate all the students into clusters. So the first one can be math major, and then English major, nursing major, engineering major, criminal justice. Oh, that's all. So suppose that's all majors for students taking 3379. And then after we separate the big population into these clusters, or we call it subgroups or sections, then we simple random sample those clusters. For example, we're gonna sample 2 majors out of the whole 1, 2, 3, 4, 5 clusters. And then all members from math major and nursing major are now considered as the cluster sample. Let's look at another example, the area code. So if we want to do cluster sampling, we can have all the clusters just by different area codes. And then we folder sample 2 out of those total clusters. So 814 and 717. So all members have have that area code are now considered as the cluster sample. Okay. Then we finished all four important sampling techniques. And let's look at some other sampling method. Not as good as the four basic sampling technique. So in some cases, it's difficult or impossible to draw a sample in a truly random way. In this case, the best one can do is to sample items by some convenient method. A sample obtained in such a way is called a sample of convenience. A sample of convenience is a sample that is not drawn by a well-defined random method. A sample of convenience may be acceptable when it is reasonable to believe that there is no systematic difference between the sample and the population. A sample of convenience is not acceptable when it is possible that there is a system difference between the sample and the population. And let's look at another one. Voluntary response samples are often used by the media to try to engage the audience. So voluntary response samples are never reliable, because who really provide opinion is more in the negative side of the opinion. So people with negative opinions are often more likely to volunteer the responses than those with positive opinions. So again, this is biased. Okay, so after we talk about the sampling techniques, let's look at statistic and parameter. So we want to distinguish between a statistic and a parameter. A statistic is a number that describes a sample. A parameter is a number that describes a population. Let's look at the following example. Which of the following is a statistic and which is a parameter? 57% of the teachers at Central High School are female. So this is a parameter, right? Because we have teachers at Central High School as the population. So a parameter is a number that describes a population. So we say it's a parameter. Let's look at the next one. In a sample of 100 surgery patients who were given a new pain reliever, 78% of them reported significant pain relief in a sample, right? So statistics number is a number that describes a sample. So this is a statistic. Okay, for this video, let's stop here. And then the next video, we'll talk about section 1.2, types of data. Thanks for watching.